What's up, guys? It's Kevin here again, and today I'm going to be going over a interesting topic of C-framing. And so I'm sure you guys most probably know that from the wikis and stuff like that, you can C-frame using Euler angles and stuff like that. So for example, if you wanted to rotate something about like the x-axis, y-axis, z-axis, you would use the Euler angles. So today I want to talk about an interesting topic of like how do I rotate an object in a certain position. So let's go back to Studio. So for example, we have two models. We have a has and don't has. Okay, so what that means is has means it has the C-framing done by Quaternions, and then the don't has means that it has the C-framing done through Euler angles. And I'll tell you guys why one is better than the other. So why Quaternions is actually much more easier to use. Well, not easier to use, but much more specific and gives you more control. So let's go back to don't has. Okay. So if I run the script, now this is a very basic function, I'll explain it right now. So first we define the parts at the top. So part that has is there, part that don't has is there, and then our function. So the function for has, don't has. So this is typically how you guys would make it spin. So like if we run it right here, as you can see, this thing is not spinning because I did not call the function. Okay. Alright, so let's click play, and as you guys can see, it's spinning, right? Now it's spinning in place. Alright, now if we go back to the script right here, I said local theta is equal to 0. Okay, so that's basically the angle or the Euler angle around the y-axis. Okay, we're going to do this around the y-axis. The local d theta, which means change in theta, we're just going to make that 0.1, something relatively small. That's basically the change in theta every time this loop iterates. Okay, so we have local position. Now this is pretty important because we want to save the position of the primary part. The reason why we want to do that is because we want to basically move the model back to its original position after we C-frame it. Otherwise, it's going to move a bunch of places. Now, an important thing about this to note is that we do it based off of the primary part. If you guys want to do this experiment as well, you're going to have to set the primary part of your model. So right here, we basically, put three parts side by side, and I set the primary part to that middle part. So if you guys don't know how to do that, you just go to the model, go to the primary part, you click the primary part thing, and it'll ask you to like select one of these parts. So just select the part. I selected the middle part, so like you can just click on here or you can click on the Explorer, it doesn't matter. So back to this scripting stuff. We don't need this print statement, it just tells us where the position is. I just wanted to keep it just for testing purposes. So now onto the loop, which is the most important part. So while wait, so it's going to wait a short amount of time every time, and then it's going to do everything inside. Okay, so while wait do, so it's going to do a part that don't has. It's going to set the primary part C-frame based off of the Euler angles. Now, if you guys didn't know what this does right here, this function, set primary part C-frame, we can go to our object browser. So object browser you can find in the view tab. Object browser is super handy because it tells you basically what every class does. Now, it might not have some classes, you'll have to look it up on the Roblox wikis, but for the most part this is super easy to reference to. So we go to this function. So it says sets the C-frame of the model primary part, If the primary part is nil, then this function will throw an error. This also sets the C-frame of all descendants parts relative to the C-frame changed to the primary part. Now this is super important because if I rotate the primary part using this function, then it rotates the whole model for me. That's basically what it's saying, which is very powerful. So let's go back to the script. So we're setting the primary part C-frame to theta. Now C-frame from Euler Angles. Now this is interesting. So this is what I was talking about. We're going to do a test, C-frame dot from Euler Angles versus Quaternions. Okay, so C-frame from Euler Angles, basically what it's saying is it's saying what is the angle rotated around the x-axis, y-axis, and z-axis. Now unfortunately, with C-framing from Euler Angles, what it does is it moves the whole entire model to the origin. So if we put this in comments, okay, and right now we click play, okay, as you can see, it moves the model to the origin, right? We don't want that. See, notice how in our output, our position should be at this part, but we want it to rotate in place. Okay, so what we're gonna have to do is we're going to use the move to function, which is part of the model class. So again, back to our object browser, the move to says that it moves the centroid model to a specified location, respecting all relative distances between parts in the model. So so basically moves the center of the model to the right position. Now again, I recommend that your primary part be the center of the model, just because it's easier to I guess, if you will, like it's just easier to set up references and things like that. So what this does is it C-frames it and then it moves it to the correct position. Okay, now another interesting thing I found is that if you do the move to before the C-framing, then it still teleports it to the origin. So you want to have the move to after the C-framing. So after we do that, we can click play, and as you guys see, it rotates in the right position. Now the problem comes when you try and run past it. So if you guys didn't notice already, this stuff is anchored, all the parts are anchored, and the can collide is turned off, so meaning that I can run through it. But watch what happens when I do. So if you guys notice, whenever I move under it, the model teleports up. Now this is really bad, because if you want any kind of interaction between models, this adds like an unpredictability into your models and stuff, and it's not specific. It's super annoying, right? So let's see what happens whenever we move, let's just say, another model right by it, and see what happens. So for example, if you guys have a building, I don't know why I'm floating, okay, but as you guys can see, notice how when it rotates, it bumps up and down. But we don't want that. We want it to rotate in place in a specific location. Now this was really annoying when I was trying to do this laser beam in my game. I wanted the lasers to rotate, but they kept teleporting to the top of the stadium. And I'll show you guys what that looked like at the end of the video. But now this is a problem, and I've been trying to fix for a while. It's pretty ridiculous, super annoying. If you guys have like a different solution than I do, then you can just comment down below. But instead, I found an interesting solution. So what we're gonna do is we're going to copy all this stuff, okay, and we're gonna paste it here. Now don't worry guys, again, this script will be posted as a free model, so you guys can download it, do whatever you want. Doesn't matter, I don't care. I'm just trying to make it easier. Should be down in the description, the link. Just don't forget to, favorite the model, try and get it out there and stuff. Yo, what do you want? Okay, so we're going to talk about Quaternions right now for rotation. Now, if you notice, if you go back to the C-frame, you can either do from Euler Angles, which is what most of you guys probably do, or some kind of angle, or you can do something called a C-frame.new, number X, number Y, Z, number Q, and all this, like these 4 added extra stuff. So Basically what it does is it creates a C-frame from position XYZ and a quaternion QX, QY, QZ, and QW. Now this is important because if you use this kind of C-framing, then you will no longer need to do the move to function. So now I'm going to try and explain to you guys what a quaternion is and how we can use it to our advantage. So let's go back here. So again, guys, a lot of this stuff is in the Roblox wiki. All you guys have to do is Google it, but I'll try and explain as best as I can for quaternions. I recommend reading this just so you guys can have a better understanding. So basically a quaternion is a vector that, not really a vector, but okay, well yeah, it's kind of like a four-dimensional vector that's used to represent rotation in 3D space. Now to help visualize a quaternion, they have like this GIF right here, and as you guys can see, the direction of this vector describes basically the axis of rotation for this object, and then the length of the vector describes the angle of rotation. So as you guys notice, the longer the vector, the more rotated the object gets about that axis. So hopefully that makes sense. If it doesn't, you guys can read up on the wiki and it will probably make a little more sense for you guys. So back to this quaternion for axis angle. We need to figure out how do we find W, X, Y, and Z values for our quaternion. So right here they give us a simple formula. So you basically use, cosine, sine, A stands for angle, and V, which is very important, V is your unit quaternion. Now if you guys didn't know what that is, your unit quaternion is basically I'm sorry, the unit rotation axis basically has a magnitude of 1. Okay, which is very important. Make sure the magnitude stays at 1. Otherwise, it'll affect the whole entire equation. And the x, y, and z components just tell you in what direction the vector is pointing to. Now, if you guys have taken linear algebra or understood like vectors in the past, this stuff should be pretty simple. But if you don't get it, that's okay. Just know that you need to use this equation and that the V stands for a unit rotation axis. So for example, if we wanted to make our unit rotation axis in the y direction, so we wanted the part or model to rotate about the y-axis, we would say v dot x is equal to 0, and v dot y is equal to 1, and v dot z is equal to 0. That would be our unit rotation axis. The magnitude would be 1. Now, if you guys didn't know how to find the magnitude of a vector, all you have to do is just square all of its components and then square root here, let's do a quick Google search. Okay, magnitude of a vector. All right. Okay, so to find the magnitude of a vector, okay, whatever, this looks like a crappy website, but we'll just go with it. All right. Okay, so yeah, so you can use the Pythagorean theorem, but if it's a 3D vector, you would still use, like, same idea. We'll just do 3D vector. Okay, here we go. There we go. Let's see it. Okay, here we go. Yeah, so you would basically do the square root of x squared plus y squared plus z squared. Basic stuff. They have a proof on this. You guys can, it's just a bunch of math. You guys can Google up. It's fun stuff. If you like math, I don't know. But so what we're going to do is we're just going to Control C, so we're going to copy it, go back to this, and we're going to try and utilize all this information for our new model, our model that is called has. Now, another important thing that I forgot to mention is that for our quaternions, to C-frame it, you can just use this constructor, cframe.new, and then pass seven values to it, and then it will create what we call a rotation matrix that specifies the orientation of an object. Now, this is, you can calculate the rotation matrix yourself right here using the Quaternion, but that's just like a crap ton of time, and you guys probably don't want to learn how, so we'll just stick with this. This is easier. Roblox does it for us, which is awesome. So let's go back to here and go back to our script. So we have local angle theta. Okay, so is equal to 0. Local change in theta is equal to 0.1, and then local position is equal to part don't has primary part position. Now this is all very important, because now what we gotta do is we have to define certain variables. So I'm gonna paste this right in. Okay, so let's do local. Okay, we'll make it all local variables. Alright, so we have our W, X, Y, and Z. Okay, now if you guys notice the just trying to format it here, but the sine and cosine are all in like underlined as errors. What you guys have to do to access that is just do math dot. Now math dot is a really awesome, like, I guess just awesome tool to use. Sorry, excuse me. Okay, so you can do absolute value, you can do a cos, a sine, or arc sine, arc cos, you know, all that basic trig stuff, pre-calculus stuff. You can do floor, which is awesome. So like you can have certain doubles round down. So numbers with decimals you can round down immediately. This is really important because if you guys ever want to create like a point system and then you want to have like a multiplier like times 1.5, but you don't want to have decimal points, so you know, you use floor. But anyway, so back on topic. So yeah, we're just gonna add a bunch of math dot and then math dot. Okay, so now that we have all that set up, we also have to change, we can either change this variable a to something, or let's just change the theta to a. So a is going to stand for angle, if you guys remember, and then we're going to define our velocity, or not velocity, our unit rotation vector. So let's do that right here. Let's do local, we'll call it unit rotation. Or unit rot is equal to vector3.new, and we'll create a new vector. We'll for this basic example, as you guys remember, we wanted to rotate about the y-axis, so let's just do 0, 1, 0. That's the order. It's x, y, z. Okay, so this is good stuff. Okay, let's change all the v's. So let's do find v. That's not gonna work. All right, yeah, v's. Okay, so we're just gonna have to do this manually. So unit rotation, and then unit rotation. Okay, sweet. All right, swaggeroony pepperoni. Okay, so now that we have all that set up, okay, we want to create our C-frame. Now, if you guys didn't remember, you just do, let's copy and paste that in just so you guys don't forget all the good stuff. So let's copy, Control C, and then let's put that in comments right here. So that's what we're going to use right here, is this C-frame using Quaternions. Okay, so let's set up our basic while loop. So while, wait, okay, do. Alright, so the great thing about this is that you don't have to do the move to function like I was telling you. It does the move to using x, y, and z within the C-frame, which is amazing. So let's set up our theta. So obviously we're going to do theta is equal to theta plus d theta, or I forgot, it should be a. Now the reason why we're doing this again is so that the angle increases over time, so it'll continue spinning. Okay, so let's set up our Quaternion. Alright, so we're going to get the part don't has, okay, and we're going to set primary part C-frame, let's scroll down, primary part C-frame, and then inside it we're going to paste this long thing again. So let's do that. Alright, so now in the arguments, obviously it takes a bunch of arguments. Let's actually hit enter right here so that you guys can see everything. So in the arguments you have number x, number y, number z. Now this is basically your position. So what we're going to do is, instead of saying number x, we're going to do position dot x. Now, if you guys didn't know already, position right here is a vector 3 value. So it has member variables called dot x, dot y, and so on and so forth. So that's how you call the specific y value or specific z value. And this is super powerful too, you know, object-oriented programming as always, very nice. So, okay. So this is our qx, okay, value that we got to figure out. So our qx value, like we stated before, is math sine times unit rotation dot x. All right, so we're going to copy, and then we're going to paste that into here. All right, and then we're going to copy this and paste that into the y value, and then we're going to copy the z value and paste that into the z value right here. All right, so let me hit enter again so that you guys can see what I'm doing. All right, so now for the or for the w value, it's just gonna be math cosine angle divided by 2. So now that we got that set up, let's delete this because we no longer need it, or let's just put in comments so that you guys don't forget what's up, you know. So let's run this, and it should work out. Oh, yes, we spawned it properly. So let's run it. So remember, it's going to be the gray one, and for some reason it is not spinning, and that is because position x, part has. That's okay. So as you guys can see, that's the problem, is we did not change up the part has part, so as we defined up there. Okay, so let's try it again. Now, as you guys can see, they're both rotating. Now watch this. When I go over to the red one, the part that doesn't has, it flies up. But whenever I go to this one, I go straight through. As you guys can see, this model using Quaternions doesn't transpose randomly. It's very predictable and it's very precise. So you guys don't have to worry about it teleporting in random places, unlike this. This is bad. No like. Yeah. This is essentially what happened when I was working with my Flores sand game, and the lasers kept teleporting up, and I was actually going to die. Like it, yeah. And I had to learn vector math in 2 days, but that's okay, guys. That's all right. It's all right. So actually, I haven't done this before, but let's move each other right by each other. Let's see what goes on. Let's click play. So, okay, as you can see, the red one flies everywhere, no matter what. But notice how the gray one just goes straight, like just stays through, doesn't do anything, you know, not bothering anyone, just chilling, you know what I'm saying? But yeah, so as you guys can see that, open the start page, that Quaternions is super powerful. Now, this is a very, very, very basic example. You guys can probably make weapons, having things rotate, you know, maybe some fidget spinners here and there. And speaking of fidget spinners, I will show you guys in another video how to make a fidget spinner, how to make one rotate and stuff like that. Super cool stuff. Actually, we should do that right now. Screw it. Let's, you know, just for fun. I mean, this is like the end of the tutorial, but if you guys want to stick around and check this out, let's pull up my toolbox. Yeah, got me some fidget spinners in my models. No free models. I use this. I built this myself. Okay, not exactly proud of it, but it doesn't matter. Okay, so again, make sure that it has a primary part. So let's make it. Yeah, there we go. All right, so let's go back to our script. Let's change the part that has to spinner. All right, let's check it out. Okay, so what the heck? All right, so again, now this is a good example. So as you guys saw just now, for some reason it is spinning along its y-axis, but the problem is that it's not spinning exactly how we want it to spin. Okay, and that's because this y-axis is based off of the part's orientation itself. So if we go to, for example, the primary part, which I believe is the cylinder. Let me see what happens if I delete the cylinder. Yeah, it's the cylinder. Okay, so right here, so the cylinder, as you guys can see, the orientation right now is negative 180, 90, meaning that it's like jumbled up everywhere. All right, so that's and if we change it, okay, don't know why that was 180 in the first place. I think because it was upside down, but let's change this to 0. As you guys can see, when it's 0, when the orientation is 0, it flips lopsided. So again, another big thing to note is that the Quaternions isn't based off of our actual XYZ axis. It's really has a lot to do with the orientation of the object itself. So we have to go in here and change up some stuff. Okay, so you know how we were talking about unit rotation vector? Unit rotation vector again is basically what the object will rotate about. So again, take some stuff to mess around with, but as you guys can see, it's rotated about its y or its z axis 90 degrees. So what we're gonna have to do is let's change this up and make it 1 right here, and that should do the trick. Okay, didn't do the trick. My bad, guys. It should be about its x-axis. All right, so okay, so there you have it. It's about its x-axis. Now you guys are probably like, what the heck, Kevin? It's vertical, and yeah, it's vertical. Okay, so that's a problem. All right, so we're going to have to figure out how to make this not vertical. Let's check out what we got here. So our set primary C-frame, we are making it do a bunch of goofy things. Okay, so our XYZ unit rotation is 1, 0. So it's rotating properly. It's just that the orientation isn't exactly ideal. Instead what I do is I remember running into this problem with Quaternions. Everything has their downside. So the reason why whenever we click play and it's rotating like this is because it's all relative to the orientation of the object. So what we have to do is we have to, I guess, change it so that the angle for this is hard to explain, but because we're having it rotate about a certain axis, we can't exactly change the plane that it's rotating on unless we change the primary part. Now I remember having to do this. It was super annoying, but what I had to do is it's very simple. You just throw in another part. So we'll throw in a block, right? Let's just go into its properties. Let's make it simple, like 1, and then the size is 1, perfect. And then we're going to change it so that its position is exactly the same as the position of the middle thing of our okay, so yeah, so as you guys can see, it's directly in the middle, and then we're going to actually name it like primary just so it's easier to keep track of, and we're going to put it within the spinner, and then we'll make it transparent just cuz. So first let's set it up so that it's the primary part. Okay, and then we're going to make it transparent to make it look a bit nice. So now if we run it, because the orientation of this part, as you guys can see, is 0, 0, 0, it's going to spin among the proper axis. So yeah, okay, okay, oh man, that's just something else. All right, again, this should be 0. That should be 1 because we want to rotate it among the y-axis. Maybe, okay, it's not anchored. So okay, so yeah, I was about to say like we spawned something from like Satan or something, but there we go. Okay, so this is looking pretty clean. Check that out. Now not only that, if we move this fidget spinner to like all this other crap, it's literally not going to like it stays in place. The only thing moving is the one using the bad C-framing and the move to function, but for the most part this fidget spinner is staying in place. So again, remember, tips with Quaternions: make sure that the primary part is in the center of the object, make sure that the primary part orientation is 0, 0, 0. Very important to get the ideal rotation. Another big thing that I noticed is that if you wanted to, like for example, if we wanted to rotate this fidget spinner, so like let's just rotate it, I don't know, yeah, like that, okay, and then let's move it up. All right, so an interesting thing about this is that if we go about the primary part, this thing's orientation has changed to like -45, right? But if we click play, it'll still, okay, yeah, so it does some goofy things like that. So a big thing about this is that make sure that the orientation of the, wait, this is so crazy, what? No, wait, no way, that's so odd. Oh, okay. Sorry, guys. Sorry. I just had a brain fart. So when you change the orientation like this, you also have to change the unit rotation vector to match this, I guess, angle. So again, make sure that the orientation of the primary part is 0, 0, 0. It'll just make your life a lot easier. There are ways to calculate around it, but there's no point. You can just make the primary part transparent and like a simple block. So yeah. So there you guys have it. There is that basic demonstration of a fidget spinner. And I will be posting this script online and stuff for you guys to use and everything. So definitely check out the links down below. All this stuff is going to be on there with comments and everything. Yeah, and don't forget to subscribe and like or leave a comment, whatever, if you thought this was interesting, something like that. I'm going to exit out of this, but again, I promised you guys to show a demonstration of like the laser test that I was telling you guys about in my game. So if you guys didn't play my game already, there's this thing called laser mode, and a big thing about this, I already have it all set up and everything. So a big thing about this laser mode is that the lasers are rotating right within the arena, but the problem is that my lasers would just like fly up and everything. It's been a while since I opened this stuff up, but let's take a look at the script. So I have my lasers. Let me try and click play and see what happens, just for the heck of it. Oh man, we can get shot at today. Oh yeah, that looks nice. Okay, so yeah, these are the lasers and they're rotating actually awfully well. Okay, so yeah, game ended. I was just testing out a bunch of things with this. You know, a lot of scripting is debugging, but let's take a look. So okay, all right, so yeah, so it starts rotating. Now if I used the C-frame Euler angles, let's take a look. Yeah, so I use Quaternions here again. But let's just say if I used C-frame Euler angles just for the heck of it. So let's open up our object browser, go to C-frame, C-frame value, okay, and so C-frame it doesn't say anything, so we're gonna go to our wiki. So we'll just do from Euler angles. Let's do control. You can do. Okay, so these are just in different order. It doesn't really matter for us, I guess, for the most part. I don't know why they have that. That's interesting. But so let's take a look at this. Oh, wrong thing. Let's take a look at this. So let's go to the script. Let's comment this stuff out because we don't need it. Don't need you. All right, and then let's do it based off of Euler angles. So again, the rotation will just say about the x-axis is 0, about the y-axis we're gonna have a because that's our angle. What's nice about from Euler angles is that it's a lot easier to manage. You don't really need to do a bunch of calculations, crazy things like that, which is nice. And then we're going to do the lasers and then move to, and then let's do position. So move back to its original position and we'll see what happens. And then over here, so that's the basic good stuff. Yeah, so let's click play and see how it goes. So this is with Euler angles, and this is the problem that I was running into, and I just wanted to you know, possibly look at that. Look at that. Wait, do you see what's going on here? Why does that happen? See, like, it actually, why? And so, like, I was working on this thing for like hours, and I came to the conclusion that, I don't know, that like Roblox was just broken. But just watch, it literally just rotates up there. And so again, if you guys are creating any kind of complex thing, definitely, without a doubt, use Quaternions. Don't be dumb. Use Quaternions. Otherwise, you're gonna get something that looks like this, and it will upset you for hours. But yeah, hope you guys learned some wisdom from like my failures, because this thing took so long to learn. And maybe this might have answered some of your guys' questions about the floating models and stuff like that, and how to attack that. So yeah, don't forget to subscribe and leave a comment or a like, and don't forget to check out my game where you can see these lasers in action and fidget spinners now, because that's a new game mode. But yeah, anyways, see you guys.